I'm Sonali Kelkar, and today we are going to do the rest of the topics from the chapter Gravitation. And the topics are buoyancy. Experimentally, we have to prove the buoyant force, then the factors on which the buoyancy depends, density, Archimedes Principle, and relative density. So let's start today's session. Now, this is the experiment to study the magnitude of buoyant force. Magnitude means how much buoyant force is applied by water. Why we are taking water over here? We have taken, you can take any liquid over here, but we have taken water because water is uniformly present and it is readily available. So here this is a spring balance. Okay, you can see the spring over here, and there is a loop. On the loop we have put a stone which is tied with the thread. Now we have to measure the weight of this stone or weight of this body. The weight of the body is 60 grams. Okay, now when I immersed this object in water, what I can see over here, the weight of the body partially immersed in the liquid, and now it is showing 50 grams. Okay, but when I have immersed this object completely in liquid, I can see the weight has still reduced, that is 40 grams. So from 60 grams, okay, or from 60 gram it has reduced to 40 gram. You can also write, to be more appropriate, you can also write 60 GF to 40 GF. Why we are using GF? Because this is due to the weight is due to the gravitational pull of Earth, right? That is why. And the apparent loss is about 20 GF, right? So this loss is due to the force which is applied by water on the object, and this force is nothing but the buoyant force. So due to the buoyant force, the object has lost its weight, and the apparent loss is not the real loss. The apparent loss of an object can be measured by this experiment. Now the factors affecting the buoyant force. What is buoyant force? Again, it is an upthrust force. Okay, the factor which affects buoyant force over here, the volume of an object immersed in the liquid. Here we have taken the two objects. One is a ball and the other one is a hull. Okay, here the volume of the hull is more as compared to the volume of the ball, right? So volume of the object which is immersed in the liquid is very important. If the volume is more, what will happen? The object is going to displace more water, right? Okay, now as we have seen, this the water which is being removed or which is being displaced by an object is the magnitude of buoyant force. That means that much of buoyant force is applied by water. In the last slide we have seen that 20 gram F or 20 gram of water was replaced by an object. So weight is nothing but over here, sorry, the buoyant force is nothing but the 20 Newton which is applied by water on an object, right? So here also, if the volume is more, the more water is removed, and when more water is removed, more buoyant force is applied on an object. Okay, more buoyant force is applied on an object. If the volume is less, less buoyant force is applied by water, and because of that a body will sink, because the weight of an object or the gravitational pull by an earth is more as compared to the buoyant force. If the gravitational pull is more and buoyant force is less, definitely the object is going to sink. Okay, so the volume of an object is important for the buoyant force. Then density of the liquid. If the liquid is denser, then more buoyant force is applied. Okay, and if the liquid is less denser, the less buoyant force is applied. And here we can take an example. It will be very easy for you to swim in a Dead Sea. Now why I have taken the Dead Sea? Because Dead Sea has lot of salt in it mix. Water is really salty, so because of the salt the water is really denser. Okay, you don't have to swim in Dead Sea, you will float on Dead Sea as compared to the swimming pool where the water is a plain water. Okay, so density does affects the buoyancy. Now, as the volume of the solid object immersed inside the liquid increases, as the volume of the solid object immersed inside the liquid increases, the upthrust or the buoyant force also increases. Why? Just now I have told you, because it is replacing more and more water. When there is more and more water replaced, which is directly indicating that more and more buoyant force is applied, right? So more buoyant force is applied and our object will float. The buoyant force depends only on the volume. Very important note. Buoyant force depends only on volume, but not the nature of a solid object. Right? Here I'll take one example. If you take a coin, right? A coin. Let's take a coin which is made up of let's take steel. Okay, fine. And you can see the ship, huge ships made up of steel. They can float on water. Okay, here the metal doesn't matter. Okay, both are made up of steel, but the volume of the ship has air spaces down, and because of this air spaces the volume gets increased, right? Okay, volume gets increased, and the more the volume, the more the water is displaced and the more buoyant force is applied. Here, as you can see, this coin, or it can be anything made out of steel, both the metals are same, but it has less volume, right? It has less volume, so it will going to replace less water, less buoyant force is applied, and this object will sink. Okay. Then coming to the next point, liquid having higher density. See, liquid which have higher density. I gave you an example of Dead Sea, or where there is lot of salt. Here there is one more example. We have taken the liquid having higher density. Now this is nothing but mercury, Hg, I'll write mercury. Mercury has a density of almost 13. Okay. This mercury, as you can see, there is a nut, iron nut or the steel nut, which is stable on the mercury. Okay, it is not even immersed little bit, just stable on the mercury, because mercury has a very high density, right? So we can say that the density of liquid is very important, right? There are the two examples. You can go to the example. I have already explained you. Archimedes principle. Now, after we have done buoyancy and buoyant force, and we have already dealt with the factors that affect the buoyant force, now let's study Archimedes principle. Okay, now what does the Archimedes principle say? I'll divide this principle in two parts so that it will be easier for you to understand. In my first part, which is related to the experiment that we have done in our first slide. That is, when an object is wholly or partially immersed in liquid. Okay, we have already done this experiment. It experiences a buoyant force, the upthrust force. Okay, and this upthrust force is equal to the weight of the liquid displaced by water. Now, it experiences the upthrust force. This till here we have already seen an experiment, and this upthrust force, the liquid which is displaced by an object, okay, the upthrust force, that liquid, the weight of that liquid is equals to the upthrust force, the magnitude of the force, right? So buoyant force or the upthrust force acting on an object is equals to weight of the liquid displaced by it. This I have already explained you in my last slide. Okay, we have measured that the weight of the we have measured that when we dip certain object in fluid, or let's take in water, right? When I dip certain object in water, then because of water, it will experience the upthrust force. Okay, when you dip certain object in water, you will also experience that the level of the water definitely gets increases, right? The level of the water gets increases, and this increase in the level of water, suppose the level of water was 100 ml initially, and later on it has increased to 200 ml. Okay, so what is the difference in the two level of water? It is 200 ml minus 100 ml. Okay, so increase in the level of water is almost 100 ml. Okay, and when you measure the weight of 100 ml, because the water has a density 1 gram per cubic centimeter, right? Because the water have a density is 1 gram per cubic centimeter, so my 100 ml will come approximately, or 100 ml will come 100 grams. Okay, so there is a displacement of 100 gram. So 100 gram is nothing. This 100 gram is equals to the buoyant force acting on an object. The weight of the liquid displaced is equals to the buoyant force which is acting on an object. So this 100 gram, if I take the weight of, if I am taking a weight of 100 grams, so I will write it into 100 GF. Okay, so this weight is due to the gravitational pull of the earth, and the buoyant force will be 100 Newton. Okay, so this is the way we are going to calculate the buoyant force. Okay, application of Archimedes principle. Archimedes principle, there are certain applications of Archimedes principle. Archimedes principle is used in determining the relative density of a substance. The relative density of a substance. Then hydrometers used for determining the density of liquids are based on Archimedes principle. Then lactometers used for determining the purity of the milk are based on Archimedes principle. So for this, if you have noticed, every time we are measuring the density, or we are comparing the density of the liquid with water. Relative density is a comparison of the liquid density of a liquid with water. It is a ratio of the density of substance divided by density of water. Okay, so every substance has a particular density. Okay, if there is a change in the density, lactometer, it determines the purity of milk. Pure milk will have a particular density, right? And if there is a change in the density of the pure milk, that means there are certain impurities, or a person has mixed water in milk. That is why the density is disturbed, it has changed. So this is how we can test the purity of a substance. For example, milk, and you can also check the purity of the metals, especially gold, when it is taken in a molten form. Okay, Archimedes principle is used in designing ships and submarines also. This is to find out how much volume or how much weight a ship can tolerate, or ship can carry, how much weight, and how much it will be submerged in water. So this is completely based on the buoyant force, and which is determined by the experiments which is based on the Archimedes principle. Now the next is, when an object is placed in a liquid, two forces act on it. So we have done about the buoyant forces, but let's see what are the other force when an object is placed in liquid. This is basically this experiment we are doing. Why object float or sink in a liquid? Okay, what is the reason behind the floating? The principle of floating. So when an object is placed in a liquid, there are two forces acting on it. One force is the gravitational force, which always trying object to pull it down. Okay, which completely depends upon the weight of an object. Okay, because what is weight? Weight is equals to m into g. M is mass and g is a gravitational acceleration due to gravity, right? So the gravitational force, I will write GF force, which is acting downwards, and upward force, that is buoyant force, BF force, which is acting upward, right? So the net force applied by the buoyant force and the gravitational force, it will decide whether the object will float or whether the object will sink. So when the gravitational force is greater than buoyant force, right? So definitely the object will sink. And when the gravitational force is less than the buoyant force, the object will float. Okay, and when the gravitational force is equals to the buoyant force, then the object will immersed. Okay, object will immerse. Immerse means if this is the level of the liquid, the object will be here at a very constant place. It will stay here. Object will stay here. That's it. Okay. So let's see the three cases. We have already discussed the three cases over here. You can just go through the slides later on. Let's discuss the principle of flotation. So we have discussed about the buoyant force, right? And let's see how if the buoyant force or the weight of an object is equal to the weight of a liquid displaced. Weight of a liquid displaced is nothing but the buoyant force. The magnitude of buoyant force is nothing but the weight of the liquid displaced, right? So when the buoyant force is equals to weight of an object, then definitely that object is going to float. Okay, now let's see the density, how the density of an object affects the floating. Why the object floats or sinks when placed on the surface of water? It also depends upon the density of a two object, that is the liquid and an object which is placed on the liquid. Okay, an object will float in a liquid if its density is less than that of a liquid. We have already seen an example of mercury. Okay, mercury has a more density, and iron nut can be placed on the mercury. It will float on the mercury. Okay, then an object will also float in a liquid if its density is equals to that of a liquid. Here I can take an example of ice floating on water, right? So approximately the density of the ice is approximately equals to the density of water. Density of water is 1 gram per cubic centimeter, and of ice cube is 0.9 okay grams per cubic centimeter. Per cubic centimeter it has to be 3. Okay, so here that is why the ice floats on liquid or floats on water. An object will sink in liquid if its density is more than of liquid. We can take here an example of a container filled with water. Okay, water, as we know, has a density 1, and iron nail, if I take an iron nail, then it has the density of, iron nail has a density of 7.86. Okay, 7.86. Again, gram per cubic centimeter. Clear? So here we can see the different differences in the density. If a denser object is placed in water, which density is less than the density of an object, the object will sink. If the density of the two objects are same, then the object will float. If the density of the object and the liquid is same, then the object will float. If the density of an object is more than the liquid, the object will sink. If the density of object is less than the liquid, then the object will float. Here we can see iron block is sinking in water because iron has a density 7.86, right? And here we can see even in mercury the iron block doesn't sink because mercury has a more density. Mercury has a density of 13.54. Okay, and if I take a cork in water, cork will float because cork has a density of 0.21. Okay, so here iron has density 7.86 gram per cubic centimeter. Mercury has a density 13, and that is why the iron won't sink in mercury, but it will just be on the surface of a liquid mercury. The concept of density. Now what is density? Density of a substance is defined as mass of a substance per unit volume. Okay, in a one particular volume, that is, let's take a volume be 1 cubic centimeter, right? And we have to find the mass of that volume, right? Let me take example over here. Let me take wood, okay, and iron, okay, and one more thing, I will take wood, and let me take mercury also, mercury, right? So what I have to do is I'll take the volume of a substance, and that will be 1 cubic centimeter each. 1 cubic centimeter of wood, 1 cubic centimeter of iron, and 1 cubic centimeter of mercury. And if I weigh them, the mass, or let me find out the mass. So if I take the mass of wood, let it be as 2 gram, right? Mass of iron, let's take as 5 gram, and mass of the mercury will be 12 gram. Okay, so what I have taken the similar volume of different materials, and I found out the mass. And what I found that the mass of wood is almost is 2 gram, and iron 5, and mercury is 12. Okay, so in this case we can say that the wood is less denser than iron, and iron is less denser than mercury. So mercury is the most denser substance over here. So density is what? Is mass of a substance per unit volume of the substance, right? So density of a substance is one of its characteristic property. Every substance has its unique type of density. It is characteristic property. On the basis of the density, you can find out a particular substance, right? It is a characteristic property. So SI unit of density is SI unit is kilogram per cubic meter, that is kg per cubic meter, right? And CGS unit is gram per cubic centimeter. So this is all about the density. Now let's take the relative density. Relative, the word relative means when you relate two things, when you compare two things. So it is a ratio. Relative density of a substance, it is the ratio of the density of the substance to that of water. Simple. It is a ratio of density of substance to that of water. So this is known as relative density. So they have written here ds, density of a substance, to that of dw, that is density of water, right? So if you have given the relative density, you can find out the density of a substance, because we know that the density of water is 1 gram per cubic centimeter, or 1000 kg per cubic meter, right? So this is how is the density This is how you can find out the relative density of different substances also. And this technique always helps to find out the purity or impurities in different metals in a molten state as well as in different liquids. The relative density of substance is also defined as the ratio of the mass of any volume of a substance to the mass of equal volume of water. So mass of substance divided mass of an equal volume of water. Relative density of substance expresses the heaviness of a substance in comparison to water. How heavy the substance is as compared to water. So as the relative density is a ratio of two similar quantities, it doesn't have any unit. Relative density don't have any unit, right? So this is what is a relative density, all about relative density, and we have covered all the topic of this chapter. So here there are densities of some common substances. One is water. There is 1000 kg per cubic millimeter. In CGS it is 1, right? And relative density is 1. So relative density of water is 1. If there is any change in the relative density of water, that means something has been mixed in water. Clear? And there are they have given the different relative densities and densities of different substances over here in this chart. Here let us do an activity which is given in your book. Okay, this activity will show that buoyant force, how it applies on an object when immersed in liquid. So what you have to take, you have to take a string. This is a rubber string, okay, and a stone beaker filled with water. Now let's start the activity. Activity 10.7 asks us to tie a stone with a rubber string and compare the length of the string when the stone is in water and when it is in air. Okay, so you have to compare the length of the string when it is in air as well as when it is in water. Here you can see the length of the string over here, right? And explanation, the liquid medium exerted upthrust force. Why there is a change in the length of string? Because there is upthrust force acting in by water on the stone when it is immersed in water. Because of this upthrust force, you will find that the length of the string has decreased because this is applying on the upward direction, and this shows that the upthrust force is nothing but the buoyant force which is acting on an object. Okay, the length of the string is the stress on the string due to its weight produced by the stone. As upthrust force on the stone reduces this stress, and as a result we see the reduction in the length of the rubber string. Okay, now the fact related with this experiment, the buoyant force is proportional to the density of the fluid medium. We use this property to detect the purity of the various fluids like milk, precious metal in molten state. So this is the use of the buoyant force, or we can say this is the use of the Archimedes principle, the application of Archimedes principle. Yeah, when you dip it in the container, you'll find the water is coming out, right? Okay. And there is a buoyant force on metal, and this buoyant force equals to the liquid displaced. Okay, so we are going to check. So for that, what we have to do is we have to first weigh an object in air. Here you can see the weight of an object is coming 0.67 GF, or you can write Newton directly. Here they have written Newton. And once the object is completely immersed in water, there is a change in weight, and now the weight is 0.40 Newton. It has reduced 60 and it is 0.67 to 0.40, and it is coming 0.27, right? Here is a beaker. You have seen a beaker over here. And once the beaker was placed, the weight of the beaker was showing 0.10, right? And once the water start coming in the beaker, the weight is now showing 0.37. The weight of the water you have to find out by reducing the weight of beaker, so which is 0.37 minus 0.10, so it is coming 0.27, and here we can see that the weight of the liquid is equals to the buoyant force which is applied on this stone, because the buoyant force, due to the buoyant force, there is a change in the weight, there is a apparent loss in the weight. Okay, so this is how we can calculate the buoyant force with the help of Archimedes principle. So this is all about today's session, children. Thank you so much.